Welcome back. Integer to words. Oh, English words. Why would you convert it to English words? It'd be easier if you just convert it to Chinese words. Anyways, convert a non-negative integer, okay, so non-negative, to its English words representation. Given it, hold on, before we do that, let's start the timer, okay? So, convert a non-negative integer to its English words representation. Given input is guaranteed to be less than 2 to the power of 31 minus 1, which is approximately 2 billion-ish. Alright, 2 billion and 3, whatever it is. It looks like a phone number. Let's take a look at the examples. So we have 1, 2, 3, and then we have 123. So this simplifies the problem now. If we take a look at the somewhere between 120, now there's no n, but grammatically you're supposed to say 123, but I guess they want to simplify the question here. Now 1, 2, 3, 4, 5 to 12,345. Okay. So 1, 2, 3, 4, 5, 6, 7, 1,234,567. I sound like a robot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 is 1,234,567,891. Okay. Now, if you have done a question, on this platform before, which is convert a string to a integer, right? Convert a string to integer. Then that's similar to this question. So we are going through now for this 1, 2, 3. What we want to do is that we want to read it from left to right, right? So this is 123. So we'll get rid of 100. We'll get 100 first, right? We'll get 100 first, and then we'll get 20, and then we'll get 3, right? And now, however, when we move on to the next 3 digits or 2 digits after the first 3 digits, so we have iterate. Say we have iterated for 3, 4, 5, right? And we read it from left to right, which is 345. Now we see this 1,000. Now for these big units, so we can see big units, we have 1,000, million, billion. Now for these big units, we are reading from left to right, right? I'm sorry, from right to left, right? So we have 891, not done. 567, done. Now, when we add these big units, we're adding from right to left. So we need 2 for loops. We need 2 iterations, right? One for the big units. The other one is for the partial parse for these 3 digits. Okay, so without further ado, let's get started. And we have 5 minutes. We have about 26 minutes left. Okay, so now, first of all, we are working on strings. So I would recommend using a string builder because it's faster and thread safe. Okay, so let's have the result. Excuse me. I just had this huge bowl of curry rice. So we have the result, and in order to keep track of the big units, we need to have an index. So let's say big units, big unit index, right, is 0. Now, one more thing. Not one more thing, in addition to this big unit index. Now, we need to have an array to store these big units. So I have string where big units is, okay. So now, first of all, I leave this as empty because it's iteration from the very right end of the digit, right? We treat it like a big unit, but actually it doesn't have a word, if you know what I mean. So we start from 891. If we don't put a empty string here, when we go on the iteration, say, so this is 1000. So if we don't go on if we don't put an empty string here, and then we put 1000 at the first element, what will happen is we'll have 567,000, not 567. So we need to empty string in order to be attached to the end of 567. Now, spend too much time explaining this. Now we have million and we have billion. So these are the big units, right? Now, okay, what we need to do now is go into an iteration, and we're going to start parsing the number. So while n is not equals to 0, right? Not equal to 0. So while it's not equal to 0, we need to append. We need to append the parsed number at the end, and then parse the big units at the front, right? So we will have, what we need to do is result append parse number, parse 3 digits, right? Well, let's say we have this function that parse 3 digits, right, into English words. So parse 3 digits, and then we'll module 1000. Now this will return, but when we return, we need to attach a big unit to it, right? So which is big unit index, right, plus, I'm sorry, backward. So attach this big unit to the end. So for example, 1 billion, 1 million, 300,000. Now to keep that in mind is that this group, this set of numbers, this set of English words are going in backward order. So we need to insert it at the front of the string builder, okay? And then we will divide this number by 1000. Okay, and then at the end we'll return number, result to string. Okay. Now let's start implementing this helper function. So we have a private, and the string we have parse 3 digits. Okay. Now the argument is also a number. So now, first thing first, we need to check. We need to set up bars, like levels, right, across this number that is ranged from 0 to 999. So the first bar that we set is the hundreds, right? It's the hundreds. So we have 900, 800, 700. So first of all, if this is larger than 100, right? If number is larger than 99, so then we need 100, 200, right? So if this number is larger than 99, and then we need to append, well, I'm missing, well, we need the result set. String builder results is new string builder. Okay, so now we have this, and then if the number is larger than 99, then we need to know how many hundreds does this number have. So we'll have, so in order to know how many numbers does this number, how many hundreds does this number have, then we need to divide it by 100, right? So if we have 998 divided by 100 is 9. So if it is 99, then we will append 999 divided by 100. So we need to use it as a index, and then we'll have hundreds, right? So, we need to put it into an array of single digits, right? And then we can attach hundreds to it. Okay, so, and then close braces. So, and then what we need to do now is to create this array. So we have digits, and and then we have if it's 0, so if it's 10, so if it's 100 divided by 100, so let's say we have 150 divided by 100 here, then it's going to be 1. So it should be able to return 1, right? And then 2, and then 3, and then, well, this is the annoying part, 4, then 5, and with 6, we have 7, we have 8, we have 9, we have nope, not 10s. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we have 9 units for the digits. Okay, so we're done with this part. So if number is 99, now what we need to do now is number equal to, well, module 100, right? Now I'll just make the code look clearer. Okay, so now in module 100, and let's see, the next scenario is 80, 40, 50, 55, 60, 78, 78, 90. Okay, so next scenario is the numbers that are in between tens, right? So, well, but there's one special case is that if you move on to somewhere in between 10 and 20, you get 11, 12, 16. So I think we need to discuss this with case by case. So if so 20 is still a special number, 21, 22, 19, up until, so 19 is still a special character, a special word for 19, because it's not called 10-9. So we need to separate that case out, but anything that is above 20, so we have a 10, we have 20, 30, 40, okay, 41, 42, 22, 23, okay. So anything that is above 19, right, we need to discuss this. So 19, then we'll do pretty much the same thing, and plus the last digit, right? So we'll have results that append digits, numbers divided by 10, and then we will, well, we don't plus anything because digit is another unit, right? Digit is another unit. So digit is another case that we want to discuss. So number is equal to number divided by 10. Now if number is somewhere between 11 or, well, I'm sorry, this is the tens, we should call it tens. So if number is somewhere between 11, 12, or 13, 10, 19, and 10, then we should return it just directly, right? We should just return it directly. So if number is larger than, if it is larger than 9, oh, well, hold up. If it's 19, so after, so say we have 312. So after the first iteration, first if condition, it will become 312. So it will become 12. So this is not the condition that meets, and it will jump into this. So we will have to fall into this condition, and we will result append (10 to 20). So if it's between 9, 10, and 18, then we should be able to return it directly. We're supposed to return it directly. Now, and after that, we'll return result dot to string. All right. So 10 to 20, and then we will have to do. So from 10 to 20, we'll have 10, 11, 12, 13, 14, 15, 16, 18, 16, 17, 18, 19. So we have 10 numbers. So if it's 10, if it's divided by 10, it's 10 divided by 10 is 1. And 11 divided by 10. 10 divided by 10 is 1. 11 divided by 10 is still 1. So that's a big problem because we need to, hold on. 10 moduled by 10 is 0, right? Why was I thinking divided? Okay, so, so this is a different case now. Now, so if 10 is number module 10. So 10 module 10 is 0, 11 module 10 is 1, and you get all the way up to 9. So 0 to 9, that's a good, yeah, that's perfect, okay. So we need to, after that, now it's between 0 and 9. So we just append digits. Well, yep. So it's between 0 and 9 now. So what we need to do is, we don't actually call 0 out, but we'll put number into this. So we need to, I'm just eyeballing if this is correct or not. Digit, number, append, and then, so we need to have from 0 to 9, okay? Well, great. So we're missing one string, which is one string array of strings, which is the tens. So in order to the tens are, let's see. So we have 20. So if 20 divided by 10, so if 20 divided by 10 is 20 divided by 10 is 2. So you need to start from 2. So we'll have 2 placeholders, and we have 20 and this is 30, and then we have 40, and then we have 50, and then we have 60, 70, 80, and 90, and well, you get up to our 90s. And we are missing the 10 to 20 array. Okay, so let's get started with this. And we have a 10 to 20, which is 10. So if 10 module 10 is 0, then we need to put 10 at the 0 index. Columbus Day, whatever the day is, he colonized the entire America. Well, and gave birth to this United States of America, the country of freedom, the greatest country in the world, and the country is trying to challenge China now in terms of Taiwan and South China Sea. By the way, they both belong to China. They're both part of China, and I don't know why America is having a. Anyways, what the heck? 10 to 20. So sorry about the politics. Sorry about the politics, okay? Let's get back to this. Technology, politics shouldn't get involved with technology. Anyways, 10 to 20. So we have, so from 20, so we have 20. So I say we're gonna have, oh, okay, so 10 to 20. So it's 10, and so if 10 modulo 10 is 0, right? So, okay, so 10 and 11 and 12, 13, 14, 40, 14, 5, 15. I will say 15, 15, and then 16, and we have 17, 17, 18. Do you put double T's? Jesus. And how much time do you have, by the way? Fuck. Oh, with 4 minutes. This is a long ass question. 19. And 20. So 20 is make up by the tens. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, okay. And then we'll return this result. Okay, so since we only have 4 minutes, 3 minutes, I'm not gonna waste any time with just double checking. We'll just run the code. 96. Okay, this is expected. Okay, perfect. Jesus. Okay. Judging compile error. No suitable method found for this method. So why is that? Big bit no suitable. Well, parse 3 digits. Okay, and module by 11 plus big. Is it because complaining that I'm not appending a string? And let me see. So, oh shit, shoot. Integer, no suitable method found for append a string. Okay. Shoot, I need to look it up. Java string buffer. Yeah, this is the problem. Not string builder. I was gonna say Java string builder. Okay. Append. Append offset. So you do put the offset to it and append offset, return to string, substring, reverse. Last index of insert. You should put insert. Okay, not append. Shoot. Okay, so insert. Jesus. Come on. Compile error again. To string, not find to string. Well, 30. To okay, to string. Okay. Go. We're running out of time. Compile error. Jesus. Okay. Come on. Cannot convert to string. So line 32. Okay. To string. All right. Now you happy now? You happy now? Finished. 222. Okay. Looks like I'm missing space here. So 20. So I should put space in between. Shoot. Okay. So okay, calm down. 1, 2, 3. What should I put? and 2, well, actually the digits are always at the end, so we don't even need to attach it, right? So we have this 40 and 50 and 60 and 70 and 80 and 90. Okay, 91, 92, stuff like this. 12, I don't 1200, 1200. So if we put 100, okay, that's fine. Let's see. 3 seconds. 2, then 2, 230, 122. What the fuck? Time's up. Okay, you know what? I'll give myself 5 more minutes. 5 more minutes. All right, just give me 5 more minutes. Jesus, motherfucker. I'm sorry. Excuse my foul language. This is not me. I'm not me when I'm coding. This is. Shoot, I should blur out that curse word. All right, so we have 2. So basically, we're one index off. So the digits 0, 1, 2, 3, 4, and when it's 3 digit, so we pass it on to 9, obviously, and then 3 module append digits 3, so 0, 1, 2, 3. Why is it 2 though? Freaking hell. So 1, we have 1, and then 20, we got the 20, okay? We got 20. So 20, we append 20, we'll append 20 divided by 10, which is 2, right? So append 2, what the fuck is, append 2, so 0, 1, 2, which is 20, that's correct. And then divided by 10, we got 3. And then if this doesn't, no, so a result append digits number to string 3. So we have 3. So 1, 0, 1, 2, 3. It should be 3. I don't understand. So this is something wrong, right? Shoot. I need to debug this. So let's see what happens. What happens right now so far at this point? And I want to know what is num at this point. So num becomes 2. Jesus. Oh, freaking hell, man. What the hell are you doing? Shoot. Alright, I've given a note. Should be modulating. Well, it doesn't make sense because I was doing the same thing in another place, but I forgot to do this. Now it's good. Okay, finished. 1, 2, 3. Let's put this number. How much minute we have? 1 minute. Okay. Why am I short? 1, 2. big units plus big units index. Oh, okay, big unit index plus plus. Okay, forgot to do this. Let's see. Okay, so 1,200,000,000. The billions are not spaced, which is bad. Okay, shoot, 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 shoot. Okay, okay, 19 seconds. Judging. Okay, I think we're good. Okay, all right. Let's get started. Wrong answer? Oh, crap. Forgot to spell 100. Oh, here. Okay, so I'm guessing I should put all capitalized letters, right? So it should be 10 and 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 0. I forgot this. Shit. Okay, so if result length, is it length or size? Okay, it's length. Okay, length is equal to 0. If it's 0, then we'll return 0. And if it's not, we'll just return the string. Okay? I'll take a note here that I said I forgot about 0 the first time. Wrong answer again? 20? What the hell? Oh, I should... Fuck! So I shouldn't put a space at the end. Okay, so I should put this one, and but what if it's like 23? Then we need to space. Okay, so we'll do this. We'll put space in the front. Okay, and then we'll put space at the end, the front of all the freaking digits, and then we'll do the same. 1 billion, or 1 billion. This, yeah, it also makes sense to put the space in the front of the digits. Let's see. Okay, here 70. You're supposed to have space at the front, not at the end. 80. What are you doing here? You're putting space at the front. 90. What the heck are you doing? You're forgetting space at the front, even though I put it here. Not you did. 20, so space at the front. 13, 14, 15, and 16. 17, 18, 19, what if it's 1900, and I'll put 100 here. Okay, so now let's just put 20, so because I don't want to. What do I feel like I'm missing one space? 21, 20. Oh, yeah, this is what's gonna happen. Well, it passed. What can I have? Please let me pass. Yeah. Okay. But I don't know how to get rid of the append. Is there a better way to get rid of the end to string? So can I do a substring? Substring, okay, I can do. All right. It contains the okay. No. I'm assuming that this length is larger than 0, so it's okay. So we can put 1 because I already checked the length here. So let's see. Okay, this time should be good. This time should be good, right? I forgot about preceding space. All right, so let's get started. Hopefully this can pass. If this one doesn't pass, I'm gonna cut this video. Fuck this. X this question. Oh. Yeah, I forgot about the. Okay. So we need to get rid of the telling zeros and the trailing zero and the preceding zeros. Okay, so wait, what if why 50 has? Oh, 50 has this. Okay, shoot, I thought it was freaking hell. Okay, let me do it one more time. Wait, why? 1,000,000. Okay, I got 1 million, but I missed 1,000. So I have 1 million. Oh, freaking hell. So first of all, if you shouldn't attach. I forgot about this. So first of all, you shouldn't attach 1 million. I mean the big unit if there's no number. So okay, let's see. So if it's 0, then you shouldn't put any number. So if it's not 0, then you can do this. Okay. So let me put this number to the test. So say remember if n modulo 1000 is 0, no need to append big units. Okay, now let's test it. $1 million. Okay, 91. Okay, so okay, this time should be good. If this doesn't good, If this time it's not working, I'm freaking cut this video and screw this question. I don't care, alright? I swear. I swear. I swear. Alright. 3, 2, 1. Accept it! Okay. Alright, so this question took me, well, I didn't even keep track of the timer at the end. Took me more than an hour, it's like about around 40 minutes to finish this. So it doesn't have any complicated data structures, but it's just very tricky, and you have to consider all the test cases. Now, first thing first, one takeaway from this video is, one, if it's a 0, if in my module 100,000 is 0, no need to append the big units, okay? So, and also another thing is that you remember to put the space in front of every single unit, and then cut off the preceding 0 at the end. Now, and also if it's 0, then we should return 0. Don't forget about this. And when you module, when you move on to the next unit, you should module instead of divide. Okay, so I think that's it. But that's about it for today. If you enjoyed this coding challenge, feel free to subscribe, and I will try my best to upload videos regularly. Alright, thanks for watching, and happy coding.